start? No? All right. Okay, so I'm going to get started with the exam first. No, you guys cannot see the actual exam. So what I do is I'm going to copy and paste it and actually work out the traces as well as the pre and post condition questions. Okay. First question that you guys get, there are several variants of the same question. The first one is basically trace question with a while loop on the outside and conditional statement in the inside. So we'll go ahead and take a look at that one first. And let me start up to my library office. And we'll go from there. So the algorithm goes like this. X gets initialized to 0, and of course I have to turn off all the autocorrect options again. Okay. So we have X gets 0 as the first statement to initialize X, and then the second one initializes Y. So Y is also initialized to 0. The while loop says as long as Y is less than 2, perform another iteration. X gets, depending on the version that you're having, this is one version, is X gets X plus 4. If X is greater than or equal to 5, then we do something. X gets X minus 5. Y gets Y plus 1. And then after the end, if there's nothing after that, it's followed immediately by and while. So the first thing I'm going to do is to do the indentations first. For this question, there's no indentation part for you to do. It is already indented correctly by the time you see it. So it's fine just like this. All right. So are there any questions about the pseudocode itself before we try to trace it? No questions about the pseudocode? Okay. If there are no questions about the pseudocode, then we'll go ahead and trace it. We'll do the usual thing, start a second window to trace it. It looks like it's going to take a while to trace, because of the value. Okay, because does anyone mention that this is going to be an infinite loop? No. Okay, because it's not. Okay. So line number, we have two variables x and y. The precondition of x and y is they are both unknown because we don't need to know anything about x or y. So this will take up a little bit of the points is whether you mention as a precondition that x and y start with unknown values. Okay, because that's a convention that we have been using in this class. Yes.
If you left a blank, would that be considered known?
No. Well, in this class, I emphasized a few times that you have to use a question mark to indicate it is unknown to begin with. All right, so as a precondition, they're both unknown. On line 1, x gets initialized to 0. On line 2, y gets initialized to 0. On line 3, we evaluate the condition. Y is less than 2 is true. The most important part about the comments column is you have to indicate what condition you're evaluating and what is the result of that condition. You can basically not say is at all. You can put an equal sign here. They're both okay. Okay, you can just completely say just y less than 2 true. Okay, that's also acceptable. But you have to tell me what condition you're evaluating and what is the result of that evaluation. And because of the condition being true, we move on to line 4, which is the beginning of the body of the loop. On line 4, x gets incremented to 4 because it was 0 before. And then on line 5, we evaluate the condition of the conditional statement. X is greater than or equal to 5 is false because x currently has a value of 4 and 4 is not greater than or equal to 5. As a result of that, we get out of the conditional statement, but because the conditional statement is also the end of the entire loop, this is the time to get back onto line 3. Okay? So at this point, we go back to line 3, re-evaluate y is less than 2. Y was not modified in the previous iteration, so it is still less than 2. It still has a value of 0. Then we move on to line 4 again. X gets incremented to 8 this time because 4 plus 4 is 8. We go to line 5. x is greater than or equal to 5 is true this time. So we have to get into the then branch of the conditional statement. The then branch of the conditional statement starts on line 6. On line 6, we subtract 5 from x. 8 minus 5 is 3, and then we store that back into x. So x is now updated to a value of 3. On line 7, y gets incremented to 1. Are we still doing okay so far?
Yeah.
Okay. And then after line 7, we are done with the then branch of the conditional statement. If you're done with any branch of a conditional statement, you get out of the entire conditional statement. There's nothing after the conditional statement, meaning the conditional statement is the last statement of the while loop itself, which means this is the time that we go back to line 3 again. Go back to line 3, y is less than 2 is true because y only has a value of 1 at this point. We go to line 4 again, x gets incremented by 4. This time it goes to 7. And then we go to line 5, x is greater than or equal to 5 is true because 7 is greater than or equal to 5. And then we move on to line 6. Line 6 is going to subtract 5 from x. X goes from 7 to 2 because 7 minus 5 is 2. Then we go to line 7. Y gets incremented to 2 at this point. And then we get back onto line 3. Y is less than 2 is false at this time. And because y now has a value of 2, 2 is less than 2 is false. So we exit the loop at this point and get to post. And that's the entire trace. Are there any questions about this trace? So what I'll be looking for would be the transitions. Transition from line 3 to line 4 consistently, depending on the value of the expression. The transition from line 5 to either line 6 or directly back to line 3, depending on the result of the condition, is also something that I'll be looking for. Transitioning from line 7 to line 3 is also the transition that I'll be looking for. I'll also be looking for the correct update of the value of x and y, and just the overall sequence, and also the whether conventions are followed in the trace. So all of those things, basically the same kind of stuff that you do in your homework assignment that I use for grading your homework assignment, I'll also be using those to grade your exam question. By the time this is all graded, you will see, quote unquote, some additional assignments, except there's nothing to turn in, because I'm going to use the rubric method of grading assignments to also grade these questions in your exam. All right, so are there any questions about question number 1? Now, your particular question may be slightly different. In other words, you might have a +3 on line 4 and comparison to 4 on line 5 or something like that, okay? But the number of iterations should be about the same, if not identical. But the values that you see on those 2 columns, for variable x and variable y, those columns will have different values as a result. Are there any questions about this particular exam question? No questions? All right. If there are no questions about this one, we'll move on to the second question. The second question is also a trace question, and this one has a repeat until. This one is kind of cute, and I'll show you guys why it's cute. Does anyone recognize the pattern of question number 2? You don't remember? Okay, let me, I'm going to make it here, I'm going to reuse, the same spreadsheet, so I'm going to use sheet 3 for the algorithm. And let's see if you guys remember this one. This is one particular version of it. Yours may be slightly different. Okay, so we have repeat, y gets y minus 1, and then we have x gets x minus y minus 1 until x is less than or equal to 1. Okay, so that's one version of the test. Yours can be slightly different. In other words, you might start with different values for x and y, but then as a result, you will also have a different boundary check at the end. I think I tried to make sure that all variants have the same number of iterations. There we go. So here we have the algorithm itself. Does anyone notice anything about this one? How x and y get updated as you go through the iterations? No one? Yep.
Was the x like square rooted?
Yeah.
25.
Yep. So x goes from 36 to 25, and then y goes from 6 to 5, and then in the next iteration, 25 down to 16, and then the other one goes from 5 to 4. So that's kind of what it is. So let's go ahead and see, whether that really is the case or not, because it should be. So here we have sheet 4 for our tracing of the algorithm on sheet 3. So once again, we need comments because we have a condition to evaluate on line 6, and then we have line number, and once again we have two variables x and y. The precondition still has to state x and y are both unknown to begin with. On line 1, in this case, x is initialized to 36. On line 2, y is initialized to 6. And now we can make the columns narrower. We do not trace line 3 because line 3 really serves no purpose, so we skip line 3 all the way to line 4. On line 4, y gets decremented by 1 first, so we go from 6 to 5 in this case, and then we move on to line 5. So in this case, on line 5, x has a value of 36 to begin with. 36 minus 5 minus 5 minus 1 is basically 36 minus 11, which turns it into 25. So we store 25 here, and then we have to trace line 6 because line 6 actually has a meaning. Line 6 basically has to make a decision to see whether we want to go back to line 4 or we proceed to post. So that's why line 6 has to be traced. We evaluate the condition first. X is less than or equal to 0 is false. And as a result, because the exit condition is not met, we have to go back to line 4, which is the starting point of the loop itself. On line 4, 5 gets decremented to 4. On line 5, 25 minus 4 minus 4 minus 1 is 25 minus 9, which is 16. So you can see that x is always the square of y at the end of each iteration. Line 6, x is less than or equal to 1 is false. So basically we have the same thing here. 4 decrements to 3, and then 16 is 16 minus 3 minus 3 minus 1 is 9. We go back to line 6, x is less than or equal to 1 is false. And then we go back to line 4 again. This one is 2. 9 minus 2 minus 2 minus 1 is 9 minus 5, which is 4. And we go to line 6, x is less than, x is less than or equal to 1 is false. So we go back to line 4. This is our last iteration because x is decremented, oops, I take it back. Y is decremented to 1, and then on line 5, x is also going to become 1 because 4 minus 1 minus 1 minus 1 is 4 minus 3, which also has a value of 1. So when we get back to line 6, x is less than or equal to 1 is finally true, and that means we proceed to post. Are there any questions about this question? Yep.
If you did not trace line 6, but you still ended up with the right answer, are you going to count off every single time it doesn't hit line 6?
No, I will only count it off as missing one thing. Well, it depends. Okay, I still have not decided on the grading scheme, but it makes a difference, between a person who did not trace line 6 at all and a person who traced line 6 but got it wrong once out of this many times. So I still have to differentiate between those. Do you see what I'm saying? Yep. So you may not miss all the points. So it's that's the bottom line. You have to somehow indicate to me why you're going back to line 4. So it has to be some kind of indication. That's the entire purpose of a trace, is to kind of show why we are going to a particular line and what happens on that line. All right, so that's question number 2. And there are 20 lines of traces, and I think there should be enough space on that piece of paper for the entire trace. I tried to make sure that you guys get enough space for these traces. Question number 3 is probably I don't know, which question do you guys do not like the most?
Number 3.
Number 3? Okay,
I
so,
think it repeats.
okay,
On the loop.
sorry?
I think on the loop repeats.
Well, let's take a look at question number 3. Question number 3 is the one that starts with a pseudocode that has no indentation. So we'll first have to perform the indentation first, and then we can trace the program. And that's why this particular question also carries more points, because it has 2 stages. And you probably will see yours to be slightly different from this one, because there are several variants of this question too. But they are all structured the same way. So oops. Ooh. File. Okay, let me just double check and make sure that this is right, because I don't think it is. Yep.
Is this the one that had if not on line 4?
Some people might get that version, if
Okay.
not something. Yep. Okay, so let's see. I think I'm missing something here. Oh, okay, I miss a whole chunk of stuff.
If statement.
Hmm?
If statement.
Yeah, there's an if and the else too. Answer.
And there was one line missing to it. Line
I think I'm just missing this part here. This is line 8. On line 9 we have if x is less than 1, then x gets x plus 2, else x gets x. Okay, that's the same line as line 13. So get rid of this row. And I think that's right. Okay, this is correct. But I numbered the lines incorrectly, so I will number those incorrectly again here, just so that we can see. We don't have line 15, we have line 16 and line 17, just like that. So that's the question. Let me show the entire thing, make sure that we zoom out just one step so we can see the entire algorithm itself. All right, so there are several ways to do the indentation. You can do it from the inside out, you can do it from the outside in. You just have to do it kind of consistently, okay? Do it in a particular way. I don't know which way works out better for you guys, but outside in works out for me. So I'm gonna work from the outside in. X gets 0, does not need indentation. It's outside of any type of nesting. While is a construct that can nest something inside it. So the first thing I need to do is to find the end of this while, so that I know what is the content of this while loop that requires indentation. So I locate the end while here. This is particularly easy for this question because there's only one while. So the while here has to be ended by line 17, the end while over here. So that means everything in between, they need to be indented one level because of that. Next, I go to line 3. This one is harder because on line 3, we have a if statement, which means I'm looking for an end if to end this particular if. The question is which end if is corresponding to this if here.
If 16.
So yeah, line 16 is the one that is ending this if, but you kind of have to count and make sure, because we have an open, open, close, and then we have another open,
Number 9.
and then another close. So that means this end if is the end of this particular if. This else also belongs to this if. So that means everything in between, like these lines, they all have to be indented. Are we doing okay so far? Okay. So these have to be indented. Now what is left will be the conditional statement from line 4 to line 6. With this one, we only have one line to be indented, which is this line here. The conditional statement from line 9 and to line 13, we have 2 statements to indent because you have to deal with both the then branch and also the else branch. So that becomes the final answer as far as indentation is concerned. That's the structure of the program. So that's the first step. Now, if the first step is not done correctly, it is likely that the second step cannot be done correctly either. But some people can track it, without, the correct indentation. I cannot. I have to look at the indentation to figure out, okay, but what line is following this line and so on. So now we have the indentation done correctly. We can go ahead and perform the trace. So in this case, we have comments because we have a lot of conditions to evaluate. We have line number, and we only have one single variable x in this case. Same as before, the precondition of x is initialized to nothing, or it is stated to be unknown. And then on line 1, it is initialized to 0. On line 2, x is less than 7 is true because x has a value of 0 at this point. Going to line 3, because we have to get into the loop, x is greater than or equal to 3 is false, which means we have to go to the else branch corresponding to this if statement. If you have the indentation done correctly, the else is easy to spot because the else branch is going to have the same indentation, or the else keyword is going to have the same indentation as the if keyword itself. So the else that we are looking at should be line 8, but since we don't trace line 8 or any lines that start with an else, we continue tracing on line 9. Yep.
How many levels of indentation are there?
How many levels? At the deepest level, we have 1, 2, 3 levels.
And there's 4 open parentheses.
There are 4 open parentheses.
Like 4 if statements or.
There are only 3 levels: open, 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 close, open, close, close, close. So there are only 3 levels of parentheses at any particular time. Up to 3, I should say. Because the while is 1 level, this if is 1 level, this if is 1 level.
And the other if?
The other if is at the same level as this if here.
No, what I'm asking is that if we open a construct, though, right?
This one on line 9,
Yeah.
it opens a new construct, but it's at the same level. It's still at level 3, because when you close this end if, you'll drop back down into level 2. Right. So now we are the condition of line 3 is false, which means we have to look for the else branch, if any, of this conditional statement. And fortunately, we do. And so we're moving on to line 9 in this case, which is the beginning of the else branch of the conditional statement starting on line 3. On line 9, it is another conditional statement. X is less than 1 is true because x has a value of 0 at this point. From line 9, because the condition is true, we go to the then branch, which is on line 10. Line 10 is just adding 2 to x. X is incremented to 2 at this point. After line 10, where do we go?
14.
We go to line 14 because line 10 is the only branch of that conditional statement, of the then branch of that conditional statement. So when we are done with the then branch, we have to get out of the conditional statement. The conditional statement goes from line 9 to line 13, but there's another statement right after that we have to execute, which is on line 14. Line 14 is incrementing x from 2 to 3, and then after that, where do we go? We are now at the end of the else branch of the conditional statement starting on line 3.
Go back to 2.
We go back to line 2 because that's the only thing inside the while loop. So now we go back to line 2. On line 2, we evaluate x is less than 7. It is still true because x only has a value of 3 at this point. So now we move on to line 3. X is greater than or equal to 3 is true. Okay. So we now move on to line 4. Line 4 is asking, is x less than 5? The answer is true. Yes, it is less than 5. If it is less than 5, we go for the then branch. So we're executing the then branch of the conditional statement starting on line 4. And that's on line 5. We are adding 2 to x. X goes from 3 to 5. And then after we are done with the then branch of the conditional statement starting on line 4, we get out of the conditional statement altogether. We end up on line 7. On line 7, we add 1 to x. And then after line 7, where do we go? Line 7 is the last line of the then branch
14.
of the conditional statement starting on line 3.
14 again.
Nope, not line 14. We're in the wrong branch. That's in the else branch.
Oh, okay.
Back up to line 2.
Back up to line 2, that's right. So we go back up to line 2. As a result, and then reevaluate x is less than 7. X is less than 7 is still true. Okay, I made one mistake here. 5 plus 1 is 6, not 1. And then we go to line 3 because the condition of the loop is still true. On line 3, we evaluate x is greater than or equal to 3. It is true. On line 4, we evaluate is x less than 5. That is false. And that particular conditional statement has no else branch, so that's okay. So that means we just say, okay, then since we cannot execute the then branch and there's no else branch, we're done with this conditional statement. So we proceed to line 7. We add 1 to x. X goes from 6 to 7, and we are done with the conditional statement starting on line 3 at this point because we are now at the end of one of its branches. So we go back to line 2 right away. X is less than 7 is not true anymore. It is false. And that's how we can get out of the loop, and we get out of the entire algorithm at this point. So the grading of this one will be I'm looking for the transitions from one particular line to another line, especially the tricky ones. Like I can identify the tricky ones. The really tricky ones would be from the ones that are skipping. Okay, from line 2 to line 3, yeah, it's kind of important, but not as important as from line 3 to line 9. That one is really important. From line 14 to line 2 is important. From line 7 all the way back to line 2 is important. From line 4 to line 7 is important. Line 7 to line 2 is important. So anything that is not sequential is actually important because you have to understand the nesting structure of the program in order to find out, okay, I'm here, but where do I go next? You really need to know how the program is structured, and nested in order to answer those questions. All right. Are there any questions about this particular one? Yep.
Should we go back up just for a second?
Absolutely. I can zoom out a little bit so we can fit more stuff on the screen. Here we go. Okay. All right. Okay, last question. So you guys do not like question number 3 more so than question number 4? Question number 4 is the pre and post condition, but it is so close to your homework assignment, right? I mean, you can almost just copy and paste the template, not from your own homework assignment, from my solution to the homework assignment, and just tweak it to make it work with this particular question, right? How many people did it like that? So did you print out, my answer, and then just white out certain portions and just substitute it with stuff in this particular question? You basically can do it that way. I mean, it really is that close to the homework question.
Just ran out of time.
Hmm?
Need another minute.
Out of time. Well, that can be a problem. Yep. You know what they say, time is money.
Yes, that part I'm not getting paid.
Time is money, except for one thing, you cannot easily buy time. You can make more money, yeah, but you cannot make time. Time is something that is just gone when it's gone. All right, so we'll go ahead and open up a new Word or Word text processing document here, and then we'll go from here. Okay, so I'll first copy and paste the program first, and so we have x. Okay, let me just magnify it a little bit here. X gets J on line 2. Again, I'm going to use the tab here. We have Y gets X. On line 3, we have X gets X times 2. And then on line 4, we have Y gets Y plus 1. Okay, so there we go. The precondition is given to you as true, which means we don't know anything about the variables. Yep.
I was just wondering when we'll be able to hear a grade on this.
Say again?
When will we be able to hear a grade on this?
As soon as I'm done grading. I hate to really answer the question this way. I know your intent, you want to know a date. I cannot really predict, how long it will take me to grade it. Typically for an exam like this, I would need about 3 hours straight to grade one class. So I have 2 classes, and then plus I have another midterm coming up, today. So it will take a little bit of time. Hopefully by Thursday, we'll have some results. I will give the paper back to you, so I'm not going to keep all that stuff, so you can use it to review for your second exam and also for your final exam. So what I'll do is I'm going to do all the grading, and then I'll scan, every single, exam question or every answer. So everything that you turn into me, I will scan it and then restaple it before I give it back to you. So that's partially also why it takes so long, is because I don't mark on the paper itself. I use Moodle for all the grading purposes. But I do keep an electronic copy of every single one, so in case you lose your own copy and you say, but Tech, I think you graded me wrong, but I have just shredded and recycled my own test paper, I still have an electronic backup of that. Okay, so I think it's kind of nice, but at the same time it takes up a lot of time. I have to these unstable, pass it through the scanner, do the grading, and then restaple everything and then pass it back to you. And of course my kids are not helping. All right, so let's go ahead and start with this one. So remember the several steps that we have to do with this one. The step 1 is to identify what is the function. So on line 1, okay, so I'll just say on line 1, f of x is j. You can just say there's no inverse, okay? If you explain, because the right-hand side does not refer to the left-hand side, that's even better. But as long as you can identify what the function is, say there's no inverse, and because of that, use the forget operation, you get those basic points for pointing out what the function is, whether there's an inverse function, and as a result, what operation are we going to use. So the next step is really just to apply the forget operation. Now for this step, you have to kind of use the template, which is the post condition is based on something about the precondition, except we have to forget something. In this case, we have to forget everything that we knew about x, because x is the one being modified. And then after that, we also have to say that x and j will be the same. Yep.
Do we have to write line 1 or don't?
Well, as long as it's clear to me that reasoning applies to which line, that will be okay.
So I just started f of x equals j. That's what I just said.
It's probably clear enough for me, as long as it's consistent.
Okay.
Yeah. If you say f of x equals j, you cannot jump to post 2 equals something. I mean, it has to be in the right order. All right, so once again, this is a equal symbol, not a left arrow. It does not work with a left arrow because we need a condition that can either be true or false. A left arrow indicates an assignment operation, which means we are changing x to j. Is changing x to j true or false? It does not apply. There's no true-false value when you're dealing with an assignment operation. But when you compare x and y or x and j, now it can be either true, yes, x equals to j, or false, it is not. Okay, so that's why it is important here to use the equal symbol. And also it is important to remember the conjunction, this entire thing, is outside of the forget operation, because this is the one additional piece of information that you know after the assignment statement, not something that you're going to forget. All right, so the second line is just to apply the forget operation. Now in my case, for myself, I always expand, pre-1 to true first, so I can do it, really, really step by step. And simplification is not required in this class, so as a result, post 1, you can just say it is true and x equals j. That is perfectly okay. But if you carry this one more step and just say, well, since I already understand simplification in this case, you can also simplify it to x equals j. So both of these are acceptable answers to the first part of the question, to post 1. So after this, we will say pre-2 is post 1 because they're sequential. And now we can work on the second line. I'm just going to copy and paste the entire line so we can see the line as we work on it. So in this case, we have f of y equals x, not f of x equals x. Okay, you have to use the variable on the left-hand side inside the parentheses because that is your independent variable. X is the definition of the function itself. So you got to remember, about that. And to be consistent with my, notification, I'll just say this is on line 2. In this case, there's also no inverse because the same reasoning applies. The right-hand side of the assignment does not refer to the left-hand side, so there are no inverse functions. So once again, we use the forget operation as a result. So this is basically the same thing, following pretty much the same template, except this time we have y as the variable and not x. And depending on what you have in the previous one, you can say true and x equals j, because I'll be looking for consistency. In other words, if post 1, you use true and x equals j, but inside here you say only x equals j, then it's not consistent. You're not using, I take it back, I made a mistake here, didn't I? The forget operation just need to specify y and x are the same afterwards, okay? I apologize. It's the second step that we'll start to use that. Okay, so now we will, we have to be consistent because if you came to the conclusion that post 1 is either true and x equals j or just x equals j, when you do the forget operation, you have to be consistent. You cannot say, it is one thing at one time and then change it to something else later on. Yep.
On that first post 2, right after y equals x, would you dock us if we said and x equals j? And we're still considering the...
Say again?
On where you have post 2 right now,
Mm-hmm.
that line right after y equals x, if we just put x equals j and x equals j after that, we wouldn't be docked, correct?
It does not work out that way because x equals j is something that should appear inside the forget operation.
Oh, okay. Right.
I mean, you can, if you want to, you can change the order and say, y equals x and forget blah, blah, blah. So if you switch the order, that's okay too, because conjunction, just like multiplication, is commutative. You can exchange the two sides and it still has the same meaning.
Okay.
So if you flip the order, that's okay. Yeah. All right, so now I carry out the actual forget operation. I look at x equals j, it does not mention y at all, so there's nothing to forget, which means I get to retain the entire thing from the precondition of line 2. But as a post condition of line 2, now I have two comparisons that I know must be true. X equals j has to be true because of line 1. Y equals x has to be true because of line 2. There is no need, okay, if you want to, that's okay, but there's no need to infer that y equals j at this point, okay? But if you mention that y equals j, hey, no point is going to be deducted. It's just the same. All right. Are there any questions about line 1 and line 2? They're both using the forget operation. Yep.
Is it actually right to have the third one y equals j?
The third one, y equals j.
Yeah.
Yeah, you can use y equals
Is
j.
it right? Because I just want to know if it's right.
It is correct. Yep. It's equivalent to what I have here. But as far as you're concerned, you're not required to do any further than just the forget operation itself. Okay, so now we can say pre3 equals post 2 because those two lines are sequential. Now this is line 3. And so on line 3, we indicate f of x is x times 2, or if you want to simplify it is just 2x, which is perfectly okay. So in this case, you do have an inverse function of f prime of x equals to x divided by 2. As a result of that, we use the substitution operation. When you apply the substitution operation, the post operation becomes the precondition, but you want to look for all the occurrences of x, which is the variable on the left-hand side of the assignment, and replace each and every single one with f prime applied to x, the inverse function applied to x. And the next line I usually do, the way I do it is I expand what is pre3. It is x equals j and y equals x. We look for x, and then f prime of x is x divided by 2. So now I actually carry out the substitution operation. So we have x divided by 2 equals j. And okay, I think I have one too many parentheses here. Here we go. And y equals x divided by 2. So every occurrence of x is just replaced by x divided by 2. Are there any questions about the post condition of line 3? Okay. No questions? We'll move on to line 4. Yep, go ahead.
We can still use the multiplication sign on line 3 fx equals to multiplied by x, or is it?
On line, you mean the last line or?
No, the after you state line 3, then you have fx equals
You mean here?
up 2 lines. To the
Here?
left. There.
Yeah, if you say 2 times x or x times 2, that's fine. Yeah, just for notation purposes, as long as I understand it means the multiplication of 2 and x, it's okay. Yeah. All right, well, one more line to go and we are done with the exam questions. So on line 4, the precondition of line 4 is the post condition of line 3. And on line 4, we applied pretty much the same reasoning as on line 3, except we applied it to y.
Oh, just back for a minute. On line 3, can you also write as f of x equals 2, then parentheses put x in there?
Say again?
Is it
F prime or f?
over to your left a bit, right there? Put the parentheses, put the x inside the parentheses.
As long as it still means the multiplication of 2 and x. Yep. All right, so f prime of f of y on line 4 is defined to be y plus 1. So this time we do have an inverse function as well. It is y minus 1. And because of that, we use the substitution operation. So once again, we apply the template. The post condition of line 4 is the substitution. We change something in the precondition of line 4. Whenever we see y, we replace that with f prime of y, the inverse function applied to y. And the next line, I just expand everything. In this case, we have x divided by 2 equals j, and y equals x divided by 2 as the original precondition. We look for y, and then we replace each y with y minus 1. And then the last line is the actual substitution operation. So we have x divided by 2 equals j. That does not get affected because it does not mention y at all. And then the other one has y, so now we have y minus 1 equals to x divided by 2. And that's the entire pre-post derivation. But there's one little extra part to the exam question. Okay, before I go any further, I will pass the row sheet for today. This is the row sheet, but since I did not use it for the past few classes, so I'm changing the column. So column 2 is the column for today.
Did you already pass back the test?
Oh, no.
He hasn't
No.
graded yet.
Oh, okay.
Yep.
I think they gave me a different test, right?
Yeah, yours is a little bit different. I think you
And
got the
then looking at
1030.
this,
It is close enough, but it's also different.
Yeah.
All right, so in this case, the question is not ended yet because there's a second part of the question. Once you get post 4, do some additional analysis. It is observed that immediately after finishing line 4, y ends up with a value of 5 in this case. I mean, yours can be different. Deduce the values of x and j using post 4. Okay, so that means post 4 is all of this stuff here. Okay, so we'll apply all of this stuff here. And also, I observe that y has the value of 5. So the question now, is can I use this to find out the exact value of both x and j?
Yes.
Okay, we can. So how do we do this? Now this implies, what does it imply? The first one that we can solve would be x. Okay, so when you look at the way x is defined, x divided by 2 is y minus 1. Y is 5, so y minus 1 is 4.
Times 2.
X divided by 2 is 4, so x has to be 8. Now once we know that x is 8 on top of y being 5, we can now solve the first one, which means 8 divided by 2 is j, so that means j is 4. So we can actually find out what the other values are because we already know how y relates to at least one of the other, and then the other one links to the last one. All right, so that's the entire answer to the midterm. And the way I'm going to grade it is, I will give you guys partial credit, as long as you can demonstrate, certain key concepts that I'm looking for. So if you get the final answer wrong, it's not the end of the world. It's, you will still get partial credit as long as, some of the intermediate steps are done correctly. All right.
Even if you mess up. Even if you mess up a little bit.
Well, in a class, it is okay because in a class, what you need to do is to find out, okay, where did if you make a mistake, where is that mistake? I mean, if you don't make a mistake, hey, even better, right? I mean, that's okay. But if you do make a mistake, the key is to find out, okay, but where did I make that mistake? Why is my answer different from the actual solution? That really is the most important part. All right. Let's see, what else was I about to say? Remember. Was the test difficult? Okay, kind of what you expected.
Number 3 gave me a little.
Sorry?
Number 3 gave me a little trouble.
Sorry?
Number 3.
Number 3?
Yep.
Well, number 3 is intentionally to be like a little bit more kind of several levels of conditional statements.
Oh, you asked us to leave line 15 blank on number 3, but if we had already filled it in with pen before you said it, you didn't dock us or anything, did you?
That's correct. Your trace has to be consistent with your indented version of the algorithm.
Okay.
Yeah. So as long as that is consistent, it's okay. All right. Any other questions? All right. If there are no questions, we're going to switch gear and go back to the topic that we have started last time, but we have not quite finished it last time. We are now in topic 4, so let me switch to topic 4, and we'll do some actual algorithm design at this point. Okay, so we'll going to highlight topic 4. We are now in top-down design. So I just want to show you what slide we are on at this point, or what topic we are on at this point, and you should be reading this stuff too as you are absorbing the material in class. I really cannot preach too much about reading ahead of time and studying afterwards, because when I was in college, I did not quite do that myself. I was absorbing 95% of the material just in lectures. And I do my homework. But at the end of a semester, when you look at my textbook, other than my name penciled down, just so that I can identify my book, the books, all my textbooks are like brand new condition at the end of a semester, with the exception of calculus, because the instructor always get assign questions out of the book itself. So I do have to flip to the right pages and do the homework that way. So some people can absorb a lot of material in the lecture. I guess that part depends on the professor too. Maybe I just have super duper exceptional professors at San Francisco State University. It was actually a very good school. I liked it. The teachers actually teach, instead of in some other universities that I have been to, where the professors usually just want to do research. So they talk about the research topic in a regular classroom, and they assign those questions too. So when you look at the question, it's like, how come this has nothing to do with the textbook or anything that the professor has talked about in the class, because it's a research topic.
What's the tuition rate you're at?
And you pay a lot of money for that too, yes. But I have to say that lawn is greener. All right. So we'll get started with a top-down design, and I think last time we have already started to look at factoring, right? So what we'll do today is we'll try to write an algorithm to do all that factoring. Okay, let me just remind you guys. Don't remember any factoring things? Okay, factoring is like this. Let me change my.
Where you constantly reduce to the small set.
Yep,
Okay.
I want to find out all the prime factors of a particular number. That's basically what we were talking about. So let's just refresh your memory a little bit before we actually work on the algorithm. So if I pick a number like 80, okay, and I want to find all the prime factors of 80, I can express 80 as 2 times 40. I start with a smaller one, okay? So we identify 80 to have one prime factor of 2, but once you identify a prime factor, then I have the remaining portion to deal with, which is 40 in this case. So now I look at 40 and go, well, it has another 2, okay, it's 2 times 20. I look at 20, and it has 2, 10. I look at 10, it has 2, 5. I look at 5, and it go like, oh, 5 is its own prime factor, which is 5 times 1. And by the time I get to 1, I don't have to go any further, because 1 does not have any prime factors. 1, by definition, is not even a prime number. Yep.
Does it always have to be the smallest prime factor on the left?
It makes it more systematic.
Oh, okay.
Okay, so a lot of times, when we do things, we do it with what I would call the eyeball algorithm. In other words, we pick the obvious stuff to work on first. But when you program a computer, you need to make it more systematic, so that it is just it's more easier. It's easier to specify the steps to do. Okay, so this is one example, and then I can give you another example. What if you're given a number that is prime to begin with? Let's say 13. Well, 13 is just 13 times 1, because 13 is its own prime factor. Okay. All right. So we'll go ahead and take a look at this approach, and then we say, but how do we, use this as an example? You do it by hand a few times, and you say, okay, I think I know how to do it. The question is, how do you encode this logic into pseudocode? Once you have the pseudocode, translating that pseudocode into C++, into Java, into Perl, into PHP, into Python, into Visual Basic, should be a mechanical step, because all modern programming languages are about the same, okay, in terms of what they can do. The syntax can be different, but they can still do whatever you specify, or whatever logic you want to specify. So the way we do it now is, okay, but how do we get started with writing an algorithm? I mean, that's like, I'm starting with a blank piece of paper here, okay? So how do we get started? And I think this really is the hardest step for some people is, how do I get started? I know how to do it by hand, I know how to do it, myself, but how do I write the code, the logic to do these operations? So what I'm trying to do at this point is to give you at least some step-by-step thinking process, and as a step, okay, I need to first consider this, okay, and then I would need to consider this, consider this, consider this. So with each step, I'm refining the logic. I do not start with, oh, okay, I think this is a repeat loop, or I think this is a conditional statement. I just start with something simple. Okay, so I'm using this to separate, the algorithm from the example here. Okay. So the first thing we need to do is to kind of think about this process and ask, is it repetitive? Is it a repetitive process? In other words, am I reapplying some logic over and over and over again?
Yes.
Seems that way, right? The reason why it seems to be repetitive is in some cases, I would need about 5 iterations to get through the entire thing. And in other cases, I only need 1 iteration to go through the entire thing. So that tells me that it's not something that a conditional statement can deal with, because a conditional statement is a one-shot deal, okay? Do I do this or should I do that? That's it, okay? This is not like that. This one is more like, okay, I'm not done yet. I'm not done yet. I'm not done yet. Oh, now I'm done, okay? So it has a repetitive nature in it. So I'll just call this revision 1 so that we can refer to these revisions, if I need to. So in revision 1 of the algorithm, I'm going to do something that we have not even talked about, because it is not a pseudocode concept. I would just say that it has a loop. Now, if it has a loop, the loop has to end, right? The one thing that I'm interested in when I specify this as a loop is, can I even identify when I am stopping with this loop? In other words, I can kind of see that I'm doing something over and over again, but in all cases, it seems like there's a terminating condition here. In other words, at some point I'm stopping, at some point I'm getting out of the loop. Can anyone identify what is triggering the exit out of the loop? Go ahead.
When you're reaching a single prime factor, so like 5 or 13 or 7.
Okay, that's one way to look at it.
So when you hit an odd number,
Then I hit an odd number. Okay.
And then 3 times 3.
So if you can't divide it by 2, then you don't continue.
Okay.
Then we have to multiply by 1 to do anything.
Yep, the 1. Okay. It is the 1 that is the flag that tells me to stop, because the number on the right hand side of the multiplication, like the 40, the 20, the 10, the 5, and here the 1, and once again here the 1, that is the next number that I'm supposed to factor. Okay? Because once I factor 80 to become 2 times 40, 40 becomes the next number that I'm factoring. So when I get to 1 and say, okay, if 1 is the number that I'm factoring, I'm done, because 1 has no prime factor. 1 is not even a prime number itself. Okay? Is that making any sense? When the number that I'm supposed to factor becomes 1, I can just say, okay, I'm done here. Is that making any sense? Okay. So the way I'm going to specify this loop here, or this pseudocode, or half-baked pseudocode, is exit when the number to factor is 1. Wow. That's it. That's my first revision. Does it even look like pseudocode to you? Maybe a little bit, all the use of loop and loop thing. But it doesn't refer to variables, has no comparison. It doesn't have if, doesn't have repeat, doesn't have while. So for the most part, this is like pseudocode. Okay, this is like intermediate pseudocode or half-baked, pseudocode. But you know what? I will take it, okay, as a first step, because I can always do some refinements later. Right. So I now have the first revision, and I'm gonna say, well, what can I do about this one? How can I refine this so it becomes more like a real, algorithm? Maybe the first thing I can do is, stop referring to the number to factor, the number to factor. Maybe I should give it a name, a variable name. So this time I can just refer to n, as the number to factor. So the next thing I'm going to do is just to introduce variables to say that, okay, this variable is now responsible to be to store the number to factor. Okay, so I'm just saying, let n, the variable n, be the number to factor. Okay, well, once I do that, this entire phrase, the number to factor is 1, becomes what? How can I simplify this using comparison operators?
N equals 1.
N equals 1, very good. So this becomes, exit the loop when n equals 1. Great, I call this my second revision. Just by introducing, one, variable name in. Okay, I'm gonna copy and paste a little bit here. Okay, so what do I do next? Now that I have, the second revision, which means, I have loop, n loop, exit when n equals 1, n representing the number to factor. Now I have to think about, but n doesn't always start with 1. In fact, in all of the examples that we have, n does not start with 1. In the first example, where the blinking cursor is right now, I start with n being 80, right? In the first iteration, does that make any sense? Because I'm given the number to factor, and in this case, I'm given the number 80 to factor. So in this example, what is the next n? What is the next value of n, the next number to factor? 40, okay. So, and then it becomes 20, it becomes 10, and then it becomes 5, eventually it becomes 1, then we can get out of the loop. So now the question is, how did I go from 80 to 40? In other words, n that was given to me before the entire algorithm was 80. But after one iteration, it becomes 40. After 2 iterations, it becomes 20. What happened in each iteration? Divided by 2. Okay. Okay, so let's go ahead and see what we can say about that. Okay. What exactly is 2 to 80? How does 2 relate to 80 in that particular example? Sorry? Okay, what is the algorithm supposed to do again? Factoring, right? So how does 2 relate to 80?
Factor of 80.
It's a prime factor of 80. All right, okay. So maybe we can do something like this. Maybe we can just say find a prime factor, we call it f of n. In other words, we look at the number n and we say, just go ahead and give me one of its prime factors. Okay. So in the example here, the prime factor is 2, 2, 2, 2, and then 5. Okay, great. Now we start with n. We find the prime factor of n. How do we get to 40? In other words, how does 80 become 40 based on its own value and a prime factor that we find?
Divided by 2.
Divided by the prime factor. Okay, very good. All right, so looks like we're gonna say n is divided by prime factor f. Okay, and we might want to do one more step here. Just print the value of f because somebody has to. I have to make use of the prime factor, so I'm gonna just print it to the screen so that the end user can see. Is that working out so far? Now, how do I know all this stuff needs to go inside the loop and not somewhere else?
You have to keep doing it until you reach the final thing.
Because it is something that I'm doing repetitively. Very good. Right. So, looks good to me. Let's call this, another major revision. And so now we are moving on to revision 4. I forgot to change this to revision 3. So now let's move on to revision 4. Copy, paste. Here we have revision 4. I'm going to get rid of this one. No, I'll keep it. It's okay. All right. If you look at this statement here, can I change it so it's not wordy and use pseudocode notation? How do we change this to use pseudocode notation?
Put n divided by f. N
Okay.
equals n divided by f.
N gets n divided by f, not equals. N gets n divided by f. All right. Cool. All right. I think we're pretty much close to done with this algorithm. So we copy and paste it again, and specify the separator. Yep. Go ahead.
How does the program determine the prime factor, though? What's the reasoning behind that?
Well, that's a very good question. How does it get it done? Not what it is doing. Okay.
Correct.
So when you look at this, when you look at the line, let me just highlight the line that we are talking about here. When you look at this line here, it describes what needs to be done, but it doesn't quite say how it is done. Now with 80, 40, 20, and so on, it's easy sneaky, right? I mean, they're all divisible by 2 and 5. But if I give you like a 7-digit number and all the usual tricks that you use to determine, whether it's divisible by certain numbers does not work, then it becomes kind of a little bit harder. It's like, okay, but how do I find the prime factor of this 7-digit, really kind of odd-looking number? You know what? I'll just procrastinate. This is the only time when procrastination is proper. Okay, so I will talk about that in just a little bit. Why I say that procrastination is not a bad thing in this case. Okay, I do have one more thing to do. We have repeat until, and then we have while loops. So the question now is, well, I know it's a loop, so it has to be either a while loop or a repeat until loop, a pre-checking loop or post-checking loop. So the question is, which one is better for me to use? Should I have to always perform these steps at least once before I decide that I'm exiting, or should I put the condition ahead of the action and say that maybe sometimes I don't even want to perform one iteration?
Post-checking because there is at least one being the factor of the.
It depends on whether you can make assumptions about n. Go ahead.
Shouldn't you should actually check the value first. You should perform first and check the value, because if it starts out a prime number, you don't.
If it starts out as a prime number, you still want to print that one prime number out.
Right.
But it starts out as 1, then you have nothing to do because 1 has no prime factors. So you're absolutely right. So there are two versions here. I have revision 5A and revision 5B. In revision 5A, I specify a repeat until loop. Okay, so repeat until is easy because in the repeat until loop, we only need to know the exit condition, which we have specified already in the original algorithm. Now in revision 5B, we're going to use a pre-checking loop, which means we say as long as n does not equal to 1, do the following. Same 3 steps. The steps in between are still the same as those other steps. So the question now is, you look at revision 5A being using a repeat until loop, and you look at revision 5B being a pre-checking loop. They do exactly the same thing, but they do behave slightly differently when n equals to 1 to begin with. When n equals 1 to begin with a repeat until loop, you will end up with a problem. Because with n being 1, you cannot find a prime factor. 1 has no prime factor. Because by definition, 1 itself is not a prime number. On the other hand, if you are given that n starts with a value of 1, the second revision, or revision 5b, will work out just fine. Because you just say that, hey, n has to be something different from 1 to get into the loop. If n starts with a value of 1 to begin with, I'm just skip around the entire loop altogether. Yep, go ahead.
What is the two?
Not equal to.
Oh.
Greater, it's less than or greater than, which is the same thing as not equal to. All right, so in this case, 5b is a better solution because it works just as well as the first one, except it catches the one kind of exceptional case when n is 1 to begin with. And you can just say, hey, if n is 1 to begin with, I don't have to do a single thing. Okay, so now getting back to your question, which is the question of the day. Okay, that is the whole idea of top-down design. Is, hey, but you just say something about what needs to be done on line 1 inside the loop, which is find a prime factor f of n. But Tech, you did not quite say how it is done. Well, that was intentional because at this point we want to focus on the overall logic of the algorithm without getting into a whole lot of details. So with this code, we can kind of figure out what to do when n is not when n has obvious prime factors, right? It's only when n does not have an obvious prime factor that we have to say, but how are we going to do this? You know what? We're going to defer that discussion. But that's the whole idea of top-down design. It's just like when you have a long English paper to write. Okay, when you're dealing with the outline, you don't worry about the little details, right? You don't worry about, should I use this word or this phrase, because it seems like this one is better, but only by a little bit. You don't worry about the wording. You don't even worry about spelling for the most part, or grammar for the most part when you're doing the outline, because you just want to capture, this entire section has to get these points across. Okay, how I'm going to get those points across, or how I'm going to support my view, I'm going to deal with that later. It's the same thing here. Okay, we don't want to have to deal with a lot of detail at any particular time, so we're going to say, we'll deal with this later. That's the whole idea of top-down design. So your question really kind of highlights, this whole thing. I mean, I'm just using this as an example, but your question just kind of, answer it brings up the entire point of top-down design. Are there any questions about this process? Does everybody understand the process of designing an algorithm? In other words, how I got from revision 1 all the way to revision 5A and 5B. Because I think, with this class, the most difficult thing to teach is really the process of how do you encode a way of doing something that you already understand into pseudocode. Are there any questions about that? Any comments about writing code, or how to go from, yes, I know how to do this, but I don't know how to write it out as an algorithm? No questions? Well, we still have 4 minutes left. So what I'll do is we'll get started with this one. We may not be able to finish it, but we'll get started with this, okay? So my next problem, which is a sub-problem because of the first one, is to find a prime factor f of n. Okay. Now before you even try to write a pseudocode or an algorithm to solve a problem like this, you have to give yourself plenty of opportunities to do this by hand first. Okay? Now when I say do it by hand, I do not mean something like this. I'm not saying, find a prime factor of something that's obvious, 20, okay? That is not gonna help. Now, why is this not gonna help? Because, hey, I need to know how to do that too. That's because in our mind, we already have heuristics or rules of thumb of how to solve problems like this, okay? We already know the tricks. If the least significant digit of a base 10 number like this one ends with 0, 2, 4, 6, and 8, it is an even number, and any even number is divisible by 2. But it's really hard to encode that type of heuristic into a computer. And by the way, the computer does not even use base 10 numbers. So a lot of the tricks that we know does not work inside the computer. And for the same reason, this is also not a very good example because, just from the memorization of the multiplication table, we know that 21 is 3 times 7, right? I mean, I spent the entire 3rd grade trying to memorize the multiplication table, thanks to us having 10 fingers instead of 2. So it's not easy, okay? It's not easy to undo what we have learned already and just look at these numbers and say, well, I kind of know a prime factor of these 2 numbers. Easy sneezy, no problem, okay? So what you need to do is do something that's more like this. Okay, so let me double check, and this one cannot use simple rules. Yep, simple rules do not work on this number. Now we are talking. Because you cannot just take one glance at this number and say, this has to be a prime factor of that number. Because 2 doesn't apply here because the number does not end with an even number. 3 does not apply either because if you add up all the digits, the sum of the digits is not divisible by 3. You look at the last digit, the least significant digit, it is not a 0 nor a 5, so we know 5 is not a prime factor of this number. So now you have to really do some hard work. And it is the hard work that matters. Because when you have to do the hard work, now you have to figure out a way to systematically say, okay, I try this number, and then I try this number, and then I try this number. Okay? How many people will start with 31 as a prime number to test with this number? Or 71? Would you start with 71? How about 101? Why are you not starting with those prime numbers? I mean, those are prime numbers. I mean, they're just as legitimate as 2 and 3 and 7 and 11.
I would say start with 3.
Okay. Well, I would start with even 2. Okay, because even if you start with 2, it cannot give you the wrong answer. Okay. It seems kind of dumb, but I'm going to start with 2. If it doesn't work, I'll move on to 3. If 3 doesn't work, I will even move on to 4. In other words, I don't even bother to just use the prime numbers. I just use whatever number is next to it. Yep.
Oh, so are we just running a list of numbers until it hits one that is divisible by it, or?
Yep.
Okay.
Yep. And in the worst case, we have to run it all the way up to the number itself. Okay. In that case, the number itself is prime, and so it is its own prime factor. Okay. We are running out of time right now, and as I said, we don't have enough time to actually finish this part. On Thursday, we'll finish this part. Okay? So your job is to read my notes, on top-down design, so that you already have an idea of, how to solve this problem, and then when I go over it, it will sink in better that way.
And then we'll get the test back Thursday or Tuesday, or?
Hopefully by Thursday you'll have something back, because I grade it by questions. So I don't really grade your entire exam and then your entire exam. I grade exam question 1, everybody's question 1, everybody's question 2, and so on.
Oh, okay.
So you can get something partial by Thursday, but I really kind of doubt that I can finish the entire thing by Thursday.
Okay.
Yep.
Good question.
Go ahead. No, it's fine.
So would you basically just divide, let's say, by 2 if that has no remainder? You take the new value and do the same loop, divide by 2, by 3, by 4, by 5.
Yep, exactly.
Or if you want to be efficient, you'll just go